Hi, pre-calc class. This video is on the combination of functions. We're going to do page 1 and a little bit of page 2 in your notes as well. So first, a combination of functions. So when you're combining functions, you're combining them with either addition, subtraction, multiplication, or division. So we have let f and g be two functions with overlapping domains. Then for all x common to both domains, if you have the notation f plus g of x, that's just adding your two functions together. Where you have f minus g of x, that's subtracting the two functions. And also when you have this, don't forget to distribute the parentheses, or rather don't forget to distribute the negative sign into the parentheses. The negative sign into the parentheses. Sorry, my handwriting is bad. This notation here, fg of x, that is multiplication. So f of x times g of x. And now if you see f divided by g of x, that is doing f of x divided by g of x. Now the domain is the overlap of both f of x and g of x. So if you're adding and subtracting, multiplying or dividing, it's all numbers that are in the common domain between them. And we're going to see that a little bit in example 2, and I will go over that tomorrow as well. So if the f of x has a domain of all real numbers and g of x has a domain of all real numbers, then when you combine them, that's also going to have a domain of all real numbers. The only difference is if you're dividing. So in the case of the quotient, if you're doing f of x divided by g of x, remember here, whatever you're dividing by cannot equal 0. So we're going to do a few of these. So we want to do f plus g of x. And again, this is going to be the same thing as f of x plus g of x. So we're going to take this f of x function, and we're going to add it to our g of x function. And now we can combine our like terms. We have 7x minus 2x to give us 5x, and then negative 5 plus 3 to give us negative 2. So there's our answer for that. We're going to go back and look at the domains after we go through these. Next, we'll do f minus g of x. So again, this is f of x minus g of x. So we're taking our entire f of x function, and we're subtracting our entire g of x function. So this g of x needs to be in parentheses. So now we can distribute the negative sign because we're distributing every part of g of x to make that a minus 3 plus 2x. And now I'm going to combine my like terms. 7x plus 2x gives us 9x, and then negative 5 minus 3 gives us our negative 8. Next, we have fg of x. So this is multiplying my f of x times my g of x. So I'm going to take my f of x function of 7x minus 5 and multiply it to my g of x function, which is 3 minus 2x. So when you FOIL this out or distribute your 7x, we get 21x minus 14x squared. Now I distribute the negative 5, and we get negative 15 plus 10x. And now we combine our like terms. 21x, sorry, not an x squared. That is just an x here. There you go. 21x, and then plus our 10x will give us our 31x, and then our minus 15. And then lastly, when we divide, so this is f of x divided by g of x. So we take our f of x function, 7x minus 5, and we divide it by g of x, which is 3 minus 2x. There's nothing to simplify here. We can't factor or cancel anything. So we are done. That is our final answer here. Now, for all of these, we want to state the domain. So when you're looking at this, you want to first find the domain of f of x and g of x. So looking at f of x has a domain of all real numbers. And that's because it's just a straight line, 7x minus 5. We don't have a square root, and we do not have a denominator that we're dividing by. And so our domain for g of x is we have 3 minus 2x. That is also all real numbers. So since both f of x and g of x have the same domain, that means when you add the two functions together, they will have the same domain. When you subtract them, and when you multiply them, they will have that overlap. Now, when you divide, that's the only tricky part. When you have this function here, we are now dividing by an expression. And remember, we cannot divide by 0. So whatever's in this denominator to find your domain cannot equal 0. So if I add 2x to the other side and then divide by 2, we have that x cannot equal 3/2. So our domain in division is all numbers except for 3/2. So we write that as negative infinity to 3/2, and then 3/2 to infinity. And then we want to find f minus g of 4. So we can do this one of two ways. You can either find your f minus g of x function, like we did up top here, and evaluate that at 4. So we have 9 times 4 minus 8, which is 36 minus 8, which is 28. The other way, I think that's quicker. You can also do f of 4 minus g of 4. And you could plug that in 7 times 4 minus 5. You would get 28 minus 5, which is 23. And then you can find g of 4, which is 3 minus 2 times 4, 3 minus 8, which is negative 5. And then you would do 23 minus negative 5. That's more work, but you end up getting the same answer. But you don't have to find the domain of that. All right, so looking at, we're going to skip number 2 right now. We're going to jump down to the examples for applications. So we have a demand function for a certain product is P is equal to f of x equals 50 minus 0.05x, where P is the price of the product when X units are sold. And the cost of producing X units is given by C of X is equal to 0.09x plus 12,000. We want to find the revenue. So even if you don't take a business course and you don't know what revenue or cost or profit or all of those are, you can still solve this equation because it's just saying find the revenue. The revenue is X times f of X. So we're doing X times the f of X that's given to us here, which is 50 minus 0.05x. So we just distribute our x inside and we get 50x minus 0.05x squared. And that is our revenue function. So as long as you're following the instructions, then you're good to go here. Letter B, we want to find the profit function. And it's telling us the equation. The profit is equal to R of X minus C of X, or revenue minus cost. So we're going to take that revenue equation that we just found, 50x minus 0.05x squared, and we're going to subtract the entire cost function, which was given to us in the problem up here, 0.09x plus 12,000. So we can distribute that negative. And then we can combine our like terms. So we have negative 0.05x squared, 50x minus 0.09x, that is 49.91x, and then minus 12,000. So this is combinations of functions. We will do this next one as a warm-up tomorrow, and then move on to composition of functions for the rest of the week.